Hello, my name is Moses Ajay. In this video recording, we'll be looking into descriptive statistics and significance testing. So, we look at t-test and descriptive statistics first of all, because at the end of this presentation, we'll be looking. You should be able to apply descriptive statistics, perform some t-tests, and then chi-square test on data. Now, let's look at t-test. T-test. Now, this is used to determine if two sets of data are significantly different. For example, you could have a product that you already have in market. You have a product in market, and then you are developing another product, and you ask people, you ask their opinion about product you've already, the existing product and the one you have in the market. And the one you are the new product you are developing. So you want to look at the opinion, whether they accept it or you can ask them for rating. Okay, in terms of sweetness, what can you give to this? What can you give to the existing one, the previous one, and then the newly developed one? And you want to compare. And if you've collected the data from them, you want to compare if what they've told you if there's any difference between the result for the existing product and you compare that one with the new product. So sometimes in statistics, you could say that 2 is equal to 3 in statistics. Now, because 2 can be mean for the data you've collected for new product, and 3 could be the data. The mean is the average of the data you've collected from the new product. Now, statistics can tell you that the mean of one of the existing product and the mean of the of the new product are the same, and they are not actually the same in terms of magnitude. One can be 2, one can be 3, but the difference can be as a result of error. So what t-test is actually helping us to do is to look for significant difference. Okay, to look for if the difference is significant enough to call it a difference, or maybe the difference is due to an error. So you want to check whether the means of two groups are statistically different from each other. So let's look for now. And in this video, in this module, we're going to be focusing on a small experiment where we have n less than 50. So, and one of the conditions for t-test, for you to apply t-test, is that the data must be normally distributed, and the data is going to be an interval or a ratio data. Now, let's look at them 2 sample t-tests. Now, we have 2 independent samples, A and B. You've collected the samples, you've collected the results for product A, you've collected the result for product B, and you want to compare the 2 together. And in some scenario, the number of people that you have for A can be where you have it can be the numbers of people you have for B. So you have the same numbers of observations. So the numbers of this NA equals NB. And another thing you really need to know is the mean for A and the standard deviation for A. And also you also need to know the mean for B and the standard deviation for B, because these are the elements you'll be using to perform these are some of the elements you'll be using to perform your t-test. Now, to understand this problem, now we want to look for let's look for an example. Now, we have a new antimicrobial chemical, we call that B, and we want to test that against the existing one. We have another one that we have in market. Now, this might be a product. Now, you have a product in market, and you have a food product that you are developing. Now, you want to compare the 2 in terms of acceptance, maybe because of the regulation. You want to reduce the salt level in your product, you want to reduce the sugar level in your product, or you want to reduce the fat level in your product, and you want to compare, you want to look at the consumer acceptance in comparison with the one you have in the market. So you have the data, and this can be a particular scale where you have, okay, what do they think about the saltness, what do they think about the sugar level, what do they think about the fat level in this product, and then you have the result for A, and you also have the result for B. Now this is talking about chemical. You are looking at them. The result of bacteria K in millimeter inhibition distance on Hager plate. Now this is shown in the table. Now we want to use this test method to determine if the effect of these two chemicals are statistically different. We want to see if the effect of these two chemicals are statistically different. Now you can see with 5 and 6, somebody will say, oh, mathematically they are different. If 6 is greater than 5, oh, see 5 is also greater than 4. Look at what happened here. 5 is greater than 4 here. 7 is greater than 3. 6 is greater than 4. Somebody could say, yes, I think this has more effect on the A. B has more effect than A. But you could say that mathematically, but in terms of statistics, you want to check if that difference is not due to error. You want to check if the difference is statistically significant. So we can use t-test to do this. How do you solve this problem? Now just follow me. Now, the very first thing you need to do is to state your hypothesis. Now hypothesis, you have two. You have two hypotheses. One is the null hypothesis, and the second one is the alternative hypothesis. Null hypothesis will say there is no difference. No difference between the two chemicals. No difference between the two products. No difference between the two groups of customers. Now, and so on and so forth. Why the alternative hypothesis will say they are statistically different. The two chemicals are statistically different. Now we need to state our hypothesis that's the first thing. And the second thing we need to know is the formula to calculate our t-test value. Now here we have the formula to calculate our t-test value. Don't be intimidated by this formula. All we are seeing in this formula is the mean of A, mean of B. I mean the average value of A minus average value of B, and then this sign you see here is called the absolute value. You are interested in the absolute value, not the negative number. For example, if SA equals 2 and SB equals 4, that will be, now you can say this is going to be minus 4, but because we are really interested in the absolute value, you only need to put 2. So absolute value, that is the meaning of that the two vertical lines. So, and here underneath it, in the denominator, you have this the combined standard deviation. You know, you have standard deviation for A, you also have standard deviation for B, but we're going to be using the combined standard deviation. I will show you how to do this, okay? You don't need to worry. And then you have the square root sign, 1 over numbers of A plus 1 over numbers of B. Then another element you will need to solve this problem is the degree of freedom. And the degree of the freedom is the numbers of elements minus 1. I'm going to explain this also for you. Now, and then you also need the t-test table to solve this problem. So I will explain all of this as we go on in this video recording. Now let's look at obtaining the t-test value. The very first thing you want to do is to calculate the descriptive data for both sets of results. Now, descriptive data is talking about mean, median, mode. Although you don't need the mode, you don't need the median, but for me to expose you to descriptive statistics, so let's just look out for those elements, the range, the mean, median, mode. I think you are going to need this for your assignment. So now the very first thing you need to also know, for this, because you know mean is the average, you can solve that with our calculator. Standard deviation, yes, can be solved with a calculator, but this is the formula you need to use for your standard deviation, because this is a sample standard deviation. If it is a population standard deviation, it is going to be n underneath in the denominator. But because this is a sample standard deviation, that is why we have n minus 1. Okay, so this is the variables, and this is the mean of the data in that variable. Now we have the x is the each score, and this is the mean or the average. Then the numbers of values n, and summation means we sum across the values. That's the meaning of that sign is summation. Now let's look at how to solve this problem. Now don't forget, if you've gotten your standard deviation, your variance is easy to obtain. Your variance is the square of your standard deviation. It's as that simple. So if your standard deviation is 2, your variance is going to be what? 4. And if your standard deviation equals 3, your variance is going to be 9. Now, this is the descriptive statistic result for that data. Now, this is the data I'm talking about. I'm talking about this data, A 5 4 5 3 4, and your B equals C is 5 4 7 3. So, and then what we are trying to do is to look for the data for example, let's look at mean. If you want to calculate your mean, for example, if you want to calculate your mean in this problem is 5 plus 4 plus 5 plus 3 plus 4. So that is the summation, and that is 21. Then you have 1 2 3 4 5. So you have 5 and not 5. Our n equals 5. So divided by 5. That is the mean for your A. You do the same thing for your B. So what you need to do now is to look for. We know the mean for A. Our mean is 4.2, and then we want to look for the median. So the median is arranging them in the order of magnitude. I will start. 3 is the first one, followed by 4, followed by 4, followed by 5, and 5. So we have 3, 4, 4, 5, 5. So the median will be the middle number. And now 3, we don't remember 3, 4, 4, 5, 5. The middle number will be what? 4. 3, 4, 4, 5, 5. The middle number is going to be 4. That is the median. And the mode is the one with the highest frequency. And the highest frequency here, this is bimodal. You know, this is 5, 5. This is 4, 4. We have 2 5s. We have 2 4. So it's bimodal. Our modes here will be 4 and 5. Let's go and look at what we have in the answer. So for the first one, we have the mean 4.4, and we have the median. Then we have the mode. The mode is 5. Let's go back to that. Let's go back to that and see. So the mode is 5. Let's go back to the data. Here we have, this is 5, 5, 4, 4. The mode should be 5 and 4. Sorry, that mode should be 5 and 4 because mode is the one with the highest frequency. Let's look at the other one. This is 6. We have 2 6. So the mode here will be 6 because we have just one mode. We have just one mode here, 6. The mode in B should be 6. Let's look at that. So yes, the mode is 6. Great. So we know the median. Then don't forget the mode here should be 2. We have 5 and 4, I think. And then we have the median, the mean. That is what we've calculated before. You remember we calculated the mean together. Then we know the median and the standard deviation. All you need to do to calculate your standard deviation is to use this formula. Now you know your x for your mean. Once you've calculated your mean, so you will be taking each score from your mean, square it, plus the next score minus your mean, square it, plus the next score minus your mean, square it, plus the next score minus your mean, square it. Then you add them together, you get the top, and this one will be n minus 4. That will be n minus 1, which is going to be 5 minus 1, which is 4. You divide the sum you have on top by the denominator. You have the number here, and then you find the square root. You have your standard deviation, and your sample variance is going to be the square of your standard deviation. Remember I told you earlier. So if you want to get your standard deviation, if you have your standard deviation, the standard deviation is 0.836. If you square that, you have your sample variance, which is going to be 0.698. So approximately that is 0.7. The range is maximum number minus the minimum number. So if you know the maximum number, you take that away from the maximum minus the minimum is your range. If you go back to the data, look at the maximum. The maximum here is 5 and the minimum here is 3. So 5 minus 3 is 2. That is your range. For this one, we have the maximum number to be 7 and the minimum number is 4. The range here is 3. So you know the range is 2. The range here is 2 and the other one for B is 3. And then we know that the numbers of elements you have in A is 5 and the numbers of elements you have in B is 5. So this will called descriptive statistic result, and I think it's something you could play around with and you get the answers. Okay, now what I think is very important that I need to explain now is how do you get the combined standard deviation. You only have the standard deviation for A and the standard deviation for B. We need to calculate the combined standard deviation, and this is the formula you will need to do that. This is the formula you use for your combined standard deviation. Is the standard deviation of A square plus the standard deviation of B square, then divided by, to find the square root of that, you have the combined standard deviation. So we know that standard deviation of A is 0.836 and the standard deviation of B is 1.14. This is what we have here, is here. The standard devision of A, the group of result for A is this one, and the standard devision for B is 1.14. So we already know that. All we need now to do is to find the square root of the square of, this is the standard deviation of A, this is the standard deviation of B, divided by 2. Let's look at what happened. When you square this, you have this. When you square this, you have this. They have their variance. Add them together, you have this. Then divided by 2, you have this 0.9992. Then you find the square root. And the combined standard deviation for that sample equals 1. So we've gotten the combined standard deviation. So that is the next. The next thing to do now is to calculate the test value, the t-test value. Now we know the mean of A to be 4.2 and the mean of B to be 5.6, and we know the numbers of the items in each of them is 5 for first one and 5 for the second one. And we know that the combined standard deviation X, which is this one, is 1. So we've already gotten the data that we need for our t-test value. So we put in the value there. So this is absolute value, 4.2 minus 5.6. Now you could see, like this is what I'm saying the other time, 4.2, 5.6. Now somebody could say, they are different. This is 5.6, this is 4.2. They are different mathematically. But we need to prove that statistically. Let's see if they are different statistically or the difference is due to an error. So you have this. Now this is 4.2 minus 5.6. Then now our x, now this is divided by 1. This one is outside. The combined standard deviation is outside. Then square root 1 divided by 5, numbers of items A, plus 1 divided by 5, numbers of item B. Okay. Now numbers of items in B. So what we need now to do, when you take 4.2 minus 5.6, you will get minus 1.4. But we are interested in the absolute value. The absolute value is 1.4. Don't forget I said that earlier. Let me see if I can have that in the calculator. The absolute value is different. It's going to take, all you need to do is just to take neglect the number. You are interested, I can't find the sign in this calculator. The sign is not here. All you need to do is just to neglect the negative sign. You are interested in the absolute value. Then 1 multiplied by anything is that thing. So we leave 1 alone. Now this is square root of 1 over 5 plus 1 over 5. Then 1 over 5 plus 1 over 5 is 2 over 5. So you find the square root of that, you have 0.6325. Then you divide, you have your t-test value. Your t-test value is 2.21. That is your t-test value. Now, once you've obtained your t-test value, you also need to go and look for your t-test in the table. So let's go and look for t-test in the table. Now, something that you need to get your t-test in the table is the degree of freedom. How do you calculate your degree of freedom? For each experiment, the degree of freedom is n minus 1, is the numbers of items minus 1. Now, you look at it, we have 5 items, so it's going to be 5 minus 1. So the degree of freedom for the first experiment is 4, 5 minus 1. And the second experiment is 4 as well. So you add them together and your degree of freedom will be 8. So for the first experiment is 4, the degree of freedom for A is 4, 5 minus 1 is just as simple as that, 5 minus 1. And similarly, the degree of freedom for your B is 5 minus 1 is also 4. So all we need to do now, for the combined, we need the combined degree of freedom. So because we are using combined standard deviation, so we need combined degree of freedom. The combined degree of freedom will be 4 plus 4. Don't forget, you add the items together. It's not 9, it's 4 plus 4. You take the degree of freedom separately. Remember, you calculated your standard deviation separately before you bring them together in that formula that we use. Now, at this one as well, you calculated you need to calculate the degree of freedom separately, then you add them together. You've calculated we've calculated this, then we add them together, we have 8. Okay, so our degree of freedom is 8. Now what we now need to know is at what level are we testing this? Because the significant level can be at 5%, at 95%, it can be at 90%, it can be at 80%, but the general one, the common one is at 95% significant level. We are interested in 95% significant level, which is 95%. We are interested in significant level of 5%, which is 95% confidence interval. So now if you look at let's look at this table. This is a T table. This is a T table. So look at the significant level. We have 10% significant level, which is 90% confidence interval. We have 5% significant level, which is 95% confidence interval. We have 2% significant level, which is 98% significant, 98% confidence level. Now, so if we are not giving the significant level, we use the 5 because 5 is the common. We use 5 now, and in exam or a test, you will be given 5%. And if you are not giving, use your state that at 5% significant level, this is what you've done. So we have the degree of freedom of 8. Don't forget we've done that. And you know how we got that is the numbers of elements. We use the numbers of elements for each of the samples, then take one from each, then add them together. We have 8. So, and your significant level is 5. So you need this table. You just need to just go to the degree of freedom. The degree of freedom here is 8. You see, is 8, and our we are interested in 5% significant level, and that is 2.31. So 5% significant level is 2.31. So we know that. So we know that for the table that we use, the table for 5% significant level and the degree of freedom of 8, the value that can be read from that table is 2.31. And we already calculated our t-test value to be 2.1. Remember the formula that we used earlier? This formula, we use this formula to calculate our t-test value to be 2.21. So what we now need to do is to compare the two elements together. So we know from the table, from the statistical table, we have 231, and from the test value that we computed ourselves, we got 2.21. We need to compare the two. We need to compare the two together. So we compare the two together, and what this is telling us is that the standard is this. If your t-test value, the one you've calculated yourself, if it is smaller than the table value, then we cannot reject null hypothesis. Now, this means that this implies that the means are not significantly different. The means are not significantly different. No, you understand that. Understand that. Let me take that in another terms. Now, what I'm saying in essence is that if your t statistics from the table, the value you have from the table, if it is greater, if the value you have from the table is greater than the calculated t value, then you do not reject your null hypothesis. I'm saying the same thing but in different way. Now, what you have up here is saying that if your calculated t value is smaller, you see, it's smaller than the t statistics from the table, you do not reject the null hypothesis. What you are saying in essence that you do not reject the null hypothesis. That is to say, they are the same. The means are not significantly different. They are the same. So now let's look at what we have. In our example, we cannot reject the null hypothesis. We cannot reject the null hypothesis. That tells us that our t statistic from the table, that now if it is greater than the calculated t value, then we do not reject the null hypothesis. In our example, we cannot reject the null hypothesis because the t value, the t table value, the one we have from the table, 2.3, is greater than the t test value. Now, the t test value that we calculated is 2.1. So the one we have from the table is 2.3. So if our t statistics from the table, which is 2.3, if it is greater than the calculated t value, which is 2.1, now this is our scenario. So we do not reject the null hypothesis. So in our example, we cannot reject the null hypothesis. What we are saying in essence is that at 5% significant level, there's no significant difference between the two chemicals. There's no significant difference between the two chemicals. But if you look at the mean, let's go back to the mean. If you look at the mean, if you look at the mean for the two chemicals, now one is 4.2, one is 5.6. Mathematically, we will say they are different. 4.2 is different from 5.6. But statistically, at 5% significant level, those two figures are the same. There is no significant difference between the two chemicals. No difference between the two chemicals. So just take note of that. There's no difference between the two chemicals. There's no significant difference between the two chemicals. So at 5% significant level, if you go through the video again, you will discover that this is something that is very easy to do. Just remember all the elements that you need to solve the problem. Remember, let me just a quick recap. A quick recap is, to do that, you will need to know your mean for both items. You know your mean for both items. To do your t-test, you know your mean for both items. You know your standard deviation for both items. And you know the numbers in each of the items. So these are the three elements you need to know: mean, standard deviation, and the numbers. All of these other things that we did is because we want to talk about descriptive statistics using that example. So once you know that, you know your standard deviation for each of them, you combine. And don't forget to calculate your standard deviation. This is the formula that you need. This is the formula that you need to calculate your standard deviation. Don't forget that this is talking about each score. This is talking about mean. Then this is talking about add them together, then square them, then add all of them together. So you have 5 different elements here that you'll be adding together for each of those scores. Because you're going to calculate the standard deviation separately. So you have your standard deviation, then you combine them together using this formula. Then when you combine them together, you have your combined standard deviation to be 1. So this is just a recap. Then you know your mean, you know your numbers of items in each of them, then you know your combined standard deviation. Obtain your t-test value. Then the next thing you will do is to look for the t-test values in the tables. And to look at that value, you need to know the significant level you have, which is 5%, and the degree of freedom. Your degree of freedom is numbers of A minus 1, numbers of B minus 1, add them together 8. That is your degree of freedom. And once you know your degree of freedom, use the table with your degree of freedom of 8 and then the significant level. So you have 2.31. Our table value is 2.31. All we now need to do is to compare the table value with the calculated value. And don't forget, to do that, you need to remember this formula, that if your statistic from the table is greater than calculated t-value, then you do not reject your null hypothesis. If it is other way around, if your t-statistic from the, now what all this means is that you need to accept your null hypothesis. Now, but if it is other way around, if t-statistic from the table is less than your calculated t-value, then you accept your alternative hypothesis. Now, what that means is that you reject your null hypothesis. Now, this is saying that you do not reject, then you accept. That is what it means. You accept your null hypothesis. For this one, if your t-statistic from the table is greater than calculated t-value, then you accept your null hypothesis. When your null hypothesis is accepted, then your alternative hypothesis is rejected. Now, but if your t-statistic from the table is less than calculated t-value, then you reject your null hypothesis. And what that means is that you accept your alternative hypothesis. Now, this is a practice question for you. You have your element now. Here in this scenario, we have 1, 2, 3, 4, 5, 6, 7, 8. Now you have your numbers of elements here. We have 8. Now your degree of freedom here will be 7. Let me say 1, 2, 3, 4, 5, 6, 7, 8. Now your degree of freedom here also will be 7. So the combined degree of freedom will be what? 14. So if it's at 5% significant level, you know what it means. You can actually look at your table value for this data. You can look for your table value for this data. All you need now to do is to calculate your t-value. And to calculate your t-value, don't forget you will need your mean, you will need your standard deviation. And we already know that our n here is 8 and our n here is 8. And use that in the formula, then compare the two values together, the t values we calculated with the table values, and see if it is greater. Look at which one is greater, then decide whether you need to accept your null hypothesis or you need to reject your null hypothesis. And this is the answer you will get for that. So we've calculated all of those values. So you could see what I meant the other time. It's going to be at 5% significant level, and the degree of freedom is 14. So this is the table value. You could do that straight away. Test value, you need to do some calculation, and then please do it first before you come and have a look at these answers. Now, going to the chi-square test. Now, chi-square test is slightly different from t-test. Now, t-test, you are comparing two groups. Now, chi-square test, you are also comparing two groups, but the comparison is different. Now, here you are using this to test hypothesis about frequency of occurrence. Now, this is to assess the goodness of fit between a set of observed values and those expected theoretically. Now, let me just look at a scenario. The scenario could be you want to know in the population. Now when you are doing an experiment, sometimes because of cost, you are only dealing with samples. And chi-square test can help us to check if that sample is a representative of the population. Now, if we are doing an experiment to know the acceptance of a particular product by a group of people, and you know that, for example, people living in the UK, and you discover that it's going to be very expensive to look at all the people in the UK to do that. It's not feasible. So you can say, okay, let me just select 100 people. Let me do this test on 100 people. Now, you want to see if those 100 people, what they are saying is the same thing with what will happen in the entire country. Now you look at the past trend, you look at what people have been saying in the country, and you discover that the trend has been 50-50. Okay, 50 likes, 50 dislikes. So 50% like, 50% dislike. You know that is the trend. Now you ask 100 people to see if they'll be saying the same thing in conjunction, the same thing with what people in the population are saying. Now, you can use chi-square test to actually verify that. Let's look at an example. This problem are best explained using an illustration and an example. Now you need to know it's going to be 2 or more. It can be 2 or more. It can be 3 categories. It can be 4 categories. You can have you can be looking at what 2 categories of people are saying, or what 3 categories of people are saying. You can look for it can't just be one. It has to be 2. I will explain what this means with an example. Now it's going to be an independent observation, and you need a sample size of at least 10. Then random sampling is required. All observation must be used. For the test to be accurate, the expected frequency should be at least 5. In each of the cell for the table, you have at least 5. I will explain what this means. Now let's look at an example. Now here we have at least 39 and 61. So we have more than expected value. So the expected value is 5. So we have more than expected value. Now look at this. Now we have 100 persons. So they do a test, and maybe the 39 fail, 61 fail. But in the past, this is what we have in the population. This is what we have. It is 50% pass, 50% fail. Now we want to see if this is the same thing with what happened in the past in the population proportion. Now this might be for a product. Let's look at it. Let's look, because I don't like talking about failure, because I want my students to excel, to pass, to do very well. Let's talk about products. Now we have 100 persons completed a sensory test for a trial for a food product. The results showed that 39 people disliked that product, while 61 people like that product. Does this test result differ significantly from a population that often shows 50% like and 50% dislike? Now we know what is expected. The expected is 50% like, 50% dislike from the population. Now, but in the test we've done, we have 39 people dislike and dislikes, and 61 people like the product. 39 people dislike the product, while 61 people like the product. Now, for chi-square test, you need to remember this formula, and the formula says summation of the observed minus expected divided by square that, then divided by the expected. Now let's apply this formula. Let's apply this formula so that you can understand it better. Now, the chi-square is saying that, you know, observe when we did the experiment, we have 61 dislike minus 50. That is the dislike. That is the expected. That is what happened in the population. Then square that divided by the expected 50. Now plus, because we are talking about summation for all the elements, the next one is dislike. Remember we said two categories. The first category is like, the second category is dislike. It can be three categories. You can have a neutral in a neutral category, that can also be there. Now this one we have two. So we have observe, the next one is 39 dislike minus 50. 50, we know that 50 is the number of people that would that's the expected in the population, they always expect in the population 50. Then square that and divided by expected 50. So you know you can see this is the summation. This is the element that is bringing in the summation. We add this one plus this one. So we have 61 minus 50 squared that divided by 50. Then 39 minus 50 squared that divided by 50. You then add them together, you have 4.84. Now, another way of doing this to make it easy for us, another way of doing this is to use table. Let's look at this table. Now, for dislike, so observe it is 39. For like, the people that like our product, the success, succeed, or pass, it can be exam. So we know it's 61. Now, expected, we said that in the population is 50-50. So 50 dislike, 50 likes. So don't forget the total must be the same thing, 100. Sorry. If you are working in percentage, it might not be, but let's say for this one, the total is 100 for the first one, and the total is 100 for the second one as well. It might be the same, it might be different. It depends on the type of the problem, on the nature of the problem. We'll look at that later on. Now here, observe minus expected. You can see observe minus expected, O minus E. 39 minus 50, we have minus 11. Observe minus expected, 61 minus 50, 11. 100 minus 100, 0. Now, here, we need to square this. O minus E square, 11 square. When you look at it, let's look at it. 11 minus 11 square. If you minus 11, let me see if yes, there's it. Is there? Sorry. Good. If you square minus 11, you will get 121. Now, divided by expected. The expected is 50. So expected is 50. Is 2.42. Do the same thing for this. Okay, 11 square is that same thing. So divided by 50, 2.42. Now you add them together. 2.42 plus 2.42. You know, remember the formula say summation. Add the two together, you have your chi-square, which is 4.84. So you have your chi-square of 4.84 by adding the two together. Don't forget, I repeat, summation. This one plus this one will give us our chi-square. Okay, just look at it. Observe expected E and expected E square, that is this is the square. And you have for the first one, for the second one, then this is summation. Add the two together. 2.42 plus 2.42 is 4.84. So we've gotten our chi-square value. The next thing we will do, which is similar to this test, is to go and look at the chi-square statistics in the table. So don't forget our chi-square. So we have the calculated chi-square to be 4.84. Now, this is something you need to remember, which is very similar to the t-test. Now, if the chi-square statistics, that is the value from the table, is greater than the chi-square, the calculated chi-square, then you do not reject your null hypothesis. This is similar to what I've explained before. Now, that is to say, if the chi-square statistic, that is the value from the table, if it is less than calculated chi-square, then you reject your null hypothesis. That's just if you know one, you can actually tell me the other one. So now let's look at what we have. Now, to determine the chi-square statistic from the table. Now, the degree of freedom here Now you need to be very careful here. The degree of freedom in chi-square is the numbers of categories minus 1. Now how many categories do we have? We have 2 categories, like and dislike, fail, pass. Now we have 2 categories. In this case we have 2 categories. If it is like, dislike, neutral, that will be 3 categories. Now we have 2 categories. So in this case we have 2 categories. It's not going to be 2 minus 1. That is our degree of freedom. And don't forget that it is 5% significant level. Let's go to the table. Now the table is this. This is 5% significant level, 0.05. The degree of freedom is 1. You could see our degree of freedom is 1 because we have 2 categories minus 1. So our degree of freedom is 1. So our significant level that we are talking about is 5%, which is 0.05. So this is a chi-square distribution table. So we have degree of freedom 1, significant level 5%. So the chi-square value from the table is 3.8415. So we have the calculated value is 4.84. Don't forget, the calculated value is 4.84, and the one from the table is 3.84. We could see now that the calculated value is greater than the chi-square statistics. So we reject. Now let's look at what happened. Now our chi-square from the statistics 3.84 is less than calculated value. Is less. It's not greater, it's less. So we reject the null hypothesis. So if it is greater, we accept. So but now it's less, so we reject the null hypothesis. And when we reject the null hypothesis, we actually accept the alternative hypothesis, which is there's a difference. So when the null hypothesis is rejected, that shows that there's a difference. The result is significant with 95% confidence, because remember we did it is 5% significant level. So with 95% confidence, because we use 5% significant level in the table. Now the proportion of people passing the test, 61%, is significantly higher than 50% than what we have in the population. The normal one that we have in population is not due to error. The numbers of likes for our product is significantly different from the numbers of dislike, which is 39. Okay, so if you look at just look at the stat, it's very similar to t-test. Look at the value you've obtained for your chi-square statistics. Look at the value from you've obtained by calculation. Compare it together. If your chi-square is less, if your chi-square statistics is less than calculated value, you reject the null hypothesis. If it is other way around, you accept the null hypothesis. And now this is a practice question for you. What about if 42 fail, or there are 42 dislikes in the previous example, and we have 42 dislikes? Are we going to have the same result? This is going to be the answer you're going to have. Try to solve this problem and see. And again, you can also compare it at 90% confidence. Now, we've been doing 95%, which is 10%, which is a 5% significant level. 90% confidence will be 10% significant level. So you can also compare the result at that significant levels. Now, during the course of this lecture, we've covered descriptive statistics. We've talked about mean, median, mode, standard deviation, range, and we've talked about t-test and chi-square test in data analysis. Don't forget, if you have any question, feel free to email me, and then I wish you the very best. Thank you.